In today's video, we are going to be talking about Pythagoras. Pythagoras was a man from ancient Greece who was most commonly known for his Pythagorean theorem. This theorem is used to find the length of the side of a right-angled triangle, given that we already know the lengths of the other two sides. The Pythagorean theorem dictates that if we know the length of two sides, say this side and this side, we can use this theorem to find the length of the third side, which would be this side. But remember, we can only use this theorem when we have a right-angled triangle. And as we can see, we have an angle in this triangle which is 90 degrees. So that means we have a right-angled triangle and we can use the Pythagorean theorem. The Pythagorean theorem dictates that if we have a right-angled triangle, we can find the length of this side, which we have labeled A, by simply squaring and summing the remaining two sides. So that means that A squared is equal to B squared plus C squared. This is the Pythagorean theorem. Now, for this theorem to work, we need to remember that when we are summing the two other sides, that sum needs to equal the larger of the three sides. I've redrawn this triangle and I've indicated the larger of these three sides in yellow. Now, for any right-angled triangle, the largest side is always opposite the right angle. Okay, we call this longest side the hypotenuse. And this is the name given to the longest side of any right-angled triangle, and it is always opposite the 90 degrees. So just to recap, the Pythagorean theorem tells us that the length of this longest side is equal to the smaller two sides, the sum of them squared. So we sum whatever this is squared, so we square the length of B, all right, and we add it to C squared. So we find what the length of C is and we square it, and we find the length of B and we square that, and then we get A squared. Now remember, when we are finding the lengths of these triangles, rather the length of these lines, we do not want to know what A squared is. We want to know what A is. Therefore, when we just want A, we need to square root whatever B squared plus C squared was. And remember, if we were trying to find out one of the other missing sides, for example, let's say we already knew C and we already knew A, and we had to find out what B was, we would have to change this formula around to make B a subject of the formula. And I'll show you how to do that in the examples to come. So for question 1, we see that we do have a right-angled triangle, therefore we can apply the Pythagorean theorem. Okay, so which is our missing side? As you can see, we already know the length of the hypotenuse as well as one other side. So that means that we already have this as well as one other side. So we need to change this formula around so that we can find our missing side. So if we let this be A, this be B, and this be C, we can change our formula around to let B be the subject of the formula. So we will get b squared equals a squared minus c squared. And just a little bit of a hint, whenever you already know the value of the length of the hypotenuse and you are trying to find one of the other missing values, your overall formula is going to have a minus. It is only a plus whenever you have these two sides and you are trying to find the hypotenuse. Okay, because remember, your hypotenuse is always the largest value, and that is why we minus it over here. We minus from the hypotenuse when trying to find one of the other sides. Okay, we also notice that the length of A is given in kilometers and the length of C is given in meters. So we are going to need to standardize. We are going to need to pick one unit of measurement. We cannot use 15 and 9,000. So for this example, I'm going to convert them both into kilometers. It would be perfectly fine if you chose to use meters, but for the sake of this example, I'm going to choose kilometers. So with that being said, we can show that b squared equals, now remember, what is a? The length of a is 15. And just like our formula says, we are going to square it. And we minus. Now, to get from meters to kilometers, we are going to divide by 1,000. Alright, and 9,000 divided by 1,000 is 9. So, since we are working in purely kilometers, C is 9 kilometers. So, we can then punch this into our calculator, and we get that this equals 144. So, therefore, b squared equals 144. But now remember, we don't want b squared. We want b alone. To find b alone, we need to get rid of the square. And how do we get rid of the square? We square root. So we square root 144. Therefore, b equals 12. And now remember, we converted everything into kilometers. So b equals 12 kilometers. Question 2. We once again see that we are already given the value of the hypotenuse. So that means we are trying to find one of the other sides. So to find the value of this missing side, we need to rearrange our formula. So once again, we can say b squared equals, and remember the hypotenuse was always the largest value, so it's the hypotenuse minus the other side squared. Thankfully, all of our values are already in the same units, so we don't need to convert. So we say b squared equals 37 squared minus 35 squared. Remember, this was the value for A, this was the value for C. We are trying to find B. Alright, and we can see that this equals 144. And remember, we are not trying to find B squared, we are trying to find B. So we need to square root. So we can say square root of b squared equals square root of 144. Therefore, b equals 12. And we need to keep our units. We're working in millimeters. Therefore, b is 12 millimeters. As you can see from this example, they actually give you the missing side that you needed to calculate. They told you that the side is g. So it would be more correct to say g equals 12 millimeters. For question 3, we once again see that we are given our value for A we are now missing the side C. I've decided to label the side C just to show you guys that it doesn't matter how you structure your formula, as long as you understand that this rule only applies for the hypotenuse, right? The hypotenuse squared is equal to the other side squared plus the other side squared. Okay, I know I said the other side twice there, but what I meant was the other two sides, not the hypotenuse. Alright, so we then need to say c squared equals a squared minus b squared. Now, before we continue, we need to notice that this side, b, is given in millimeters, and c, or rather a, is given in centimeters. So, once again, we need to convert. We need to make sure that we are working with the same units. So, for this example, we are going to use centimeters. That would mean that we get that a squared will stay 41 squared minus, now there are 10 millimeters in a centimeter, so we need to divide 90 by 10, and we get that the side B is 9 centimeters, so we say 9 squared. We type that into a calculator, and we get 1,600. Now remember, this is what c squared is. To find c alone, we need to square root. So we can square root c squared, and we square root 1,600, and we will get that c equals 40. And what units were we working in? We decided we were going to be using centimeters. But remember, our missing side was actually f, so we say that f equals 40 centimeters. For question 4, we see that we are given all of the sides except for the hypotenuse, which I have labeled x. I've done this just to show you guys that you don't need to label them A, B, C, and the formula applies to anything as long as you're making the subject of the formula the hypotenuse when you are adding. Alright, so with that being said, we can carry on. But firstly, we need to note that this side y is given in centimeters and z is given in meters, and we want to work with the same units. So for this example, I want to work in meters. You could have chosen centimeters. So what I'm going to do is I'm going to divide 700 by 100, and that's how we get from centimeters to meters. So we say 7 squared plus 24 squared. Remember, this is all to get x squared. Alright, and once we do that, we get 6 to 5, but we don't want x squared, we just want x. Therefore, x equals 25, and that is what happens when we square root 625. But they actually give us a missing side, so then we say that b equals 25. And what units were we working in? We chose to use meters. If you'd chosen to use centimeters, you would have found that your answer should be 2,500 centimeters. For question 5, we see that we have quite a few missing letters that we need to calculate. It's no longer just one calculation. We need to find each of these. So we are going to break up this shape and do it piece by piece. So firstly, we want to figure out what this missing E is. So we can see that it is opposite the hypotenuse, so rather it is opposite the right angle, and this means that it is a hypotenuse. And we have the two other sides. So we can use our Pythagorean theorem to figure out what E is. So we can say that E squared is equal to 7 squared plus 24 squared. And this gives us 6 to 5. We square root this to find that E equals 25. Okay, so just for our own sake, we can write in here that E is 25. Alright, so we've got that. We can now move on to our next missing side. So we got E, we are now looking for G. And as we can see, this triangle G, or rather FGH, is a right angle triangle. Okay, so we have the hypotenuse already, as well as one other side. That means we are going to use the formula, which looks something like c squared equals a squared minus b squared, where a is our hypotenuse, which, like I said, we already know, so we can write that in. So c squared equals the hypotenuse we worked out earlier, 25, right? Remember, it's this side here, as well as our one other side, which is this one here. So minus 15 squared. And that gives us 400. Alright, but remember, that is c squared. So, to just find c, we square root it, and we get 20. Therefore, we know that g is equal to 20. So we can write that in. Our last missing side that we need to calculate is h. And if we have a look at this triangle, which goes J, F, H, we see that this is also a right angle triangle with the hypotenuse running from F to H. And we know that this value is 20 because we just worked it out in the previous example. So to find our missing value h, we can say that h squared equals our hypotenuse squared. Now what was our hypotenuse? We said that it was 20 squared minus the other known side, which was 12. We square that, and this gives us 256. Therefore, h would be the square root of this, which is 16. Now, for this example, they didn't give us what units we were working with, so it wouldn't be wrong if you left it like that, but we like to just say that h would be 16 units. And that is it for question number 5. For question 6, we have 2 missing sides, there and there. So to start off, we'll try to figure out what this missing side is. So as we can see, we have the triangle ABC, and the side opposite the right angle, which is the hypotenuse, is our missing side for this situation. So we're in luck and we can just use Pythagoras' theorem without needing to swap anything around. So we can say a squared equals b squared plus c squared, and we can let b be 9, square that, plus, now since we let b be 9, that means c is left to be 12. And this gives us 225. And that means that a equals 15. Since we know that A is equal to 15, we can write that in to make it easier for our future calculations. So next we are trying to find the missing side B. This is not the hypotenuse, so we are going to have to make an adjustment to our Pythagorean theorem. So we say that B squared equals, now we would usually say A squared, but remember we have to now fill in for the hypotenuse, which, as we can see from the triangle BCD, with the right angle being there, opposite the right angle we've got hypotenuse, and that is 39 squared minus our other known value, which is 15, which we calculated in the previous triangle. We square that and we get that equals 1296. So we square root that and we get that B equals 36. And once again we can say that that is units. Lastly, we have question 7, and we can see that our missing side is not the hypotenuse. So just to give you guys a little bit of insight, our hypotenuse, which we can see here is 9 as it is opposite the right angle, we can substitute this value in and we can say that 9 squared is equal to, now we can let this value over here be our B squared, rather we let that be 7 squared, and now our missing side is W, so let that be W squared. Now remember, when we're filling in, or rather when we are solving equations, what we like to do is we like to get all of our constants alone and we like to get all of our variables alone. And in this example, W is our variable, that is our unknown, whereas 9 squared and 7 squared are our constants. So we can move those over to the same side. Therefore, we can say that 9 squared minus 7 squared is equal to W squared. And this gives us that W squared is equal to 32. Remember, we don't want W squared, so we need to square root on both sides. And this gives us that W equals approximately 5.66. For those of you who don't know, these squiggly lines over there mean approximately equal to. Since I'm rounding off, it's not an exact answer, so I've approximated and I've rounded off. And that is our final answer for question number 7.